Well, dear friends, actually, in this video, I'm again will be telling you mathematical analysis of interference. Other way, there are many things which are not easily understood by students, and lot of trouble is there in this topic. So, I was explaining that mathematical sorry analysis of interference. Today I asked my students who were studying this topic, how much do you get from me? So they were unable to tell their problem, what is the problem felt by them. The interference of light actually create lot of trouble for students. I told it is superposition of light waves. You know, I have told you light waves are electromagnetic in nature, and it is the electric field vector which produces sensation of sight on our eye. Electric field. You know, electric field produce force on a charged particle. Our eye has liquid in ionic form. The electric impulse from light enter our eye and produce impulses which are periodically varying. So, in previous video I have taken superposition of y1 equal to a1 sine omega t and y2 equal to a2 sine omega t plus phi, and then I told y equal to y1 plus y2 and carried. In one year the question came like that, taking y1 equal to a cos omega t and y2 equal to a cos omega t plus phi. If these two light waves, here dear student, please listen me carefully. I am noting that I don't know what is the matter. The viewers are very small in this topic. While I was thinking that you people will like my video very much, because I am telling you this clearly and I am explaining the real fact. What is the real fact here? I am telling like that. So please listen me carefully. So I will discuss here, taking light wave having same amplitude and in terms of cos function. Our students, I feel very bad because they don't know sin A plus B. So it is sin A cos B plus minus cos A sin B. If it is cos A plus B, your minus B, then it is cos A cos B minus plus sin A sin B. Please, this much is required at least to understand this physics. If there is plus, there is minus. So, let the equation represent 1, 2. I am telling again the mathematical analysis of interference of light in terms of electric field. Here y1, y2 are the values of electric field. A are the amplitude, omega their angular frequency, phi is the phase difference between the wave. Here you can suppose that it is a particle, here charge particle, electric field y1 act this way, y2 act this way, and this is the phase difference. So what is the resultant field or what is the resultant force on this charge Q? So we have to find out that. So y is equal to y1 plus y2. These two waves, you can take reference from last video. I am telling simply interference of light mathematically. So these two waves at one point superimpose. So resultant field is this. It comes out A cos omega t plus A cos omega t plus phi. Or it is A cos omega t plus A cos omega t cos phi, or minus A sin omega t sin phi. So this way we get this solution. So y equal to A. I take here cos omega t common. So it will be A plus A sin phi. I may take A outside also, but there is reason I am not taking like that. Minus A sin phi or sin omega t. Phi is the phase difference between these two waves. So now, since A plus A sin phi and so it is cos phi here, cos phi. Now if I take here A plus A cos phi equal to A cos theta and A sin phi equal to A sin theta. I am telling because in the 1 year board exam question came from this point of view, because it is given in NCERT and students were not able to solve. Equation 3 and 4. If I put equation 3 and 4 here, what I will get? Y equal to this A cos theta cos omega t minus A sin theta sin omega t, and we get that A bracket cos omega t cos theta minus sin omega t sin theta, and it becomes A cos omega t plus theta. So this equation 5 is again equation of wave whose amplitude is capital A. Equation 5 again is the equation of periodic simple harmonic wave whose amplitude A. To find this A, we square equation 3 and 4 both sides. So squaring both sides of equation 3 and 4 and adding them, we get, I write here right hand side first. A square bracket cos square theta plus sin square theta is equal to this whole square, A square plus 2A square cos theta 2AB, or plus 2ab plus it is phi here, sorry, plus a square cos square phi plus a square sin square phi. It come out to be a square, this plus this, again a square plus a square, because I take a square common to inside sin square phi cos square phi 1 or plus 2a square cos phi, or we get here a square equal to 2a square plus 2a square cos phi. Take 2a square common, 1 plus cos phi. 1 plus cos phi. 1 plus cos phi. There is one trigonometric relation. Cos 2 theta in fact equal to cos square theta minus 1. Or 1 plus cos 2 theta is equal to cos square theta. Sorry, यहाँ 2 था, 2 cos square theta. If instead of 2 theta I use theta here, then it will become a 1 plus cos theta equal to 2 cos square theta upon 2. Please learn this formula, it will help you at many places in physics. So this thing, it becomes 2a square into 2 cos square phi upon 2, or it is 4a square cos square phi upon 2. A square, what is this capital A? It is the amplitude of resultant wave. Every wave has intensity, light wave. Intensity of light, I have told you, I equal to, in case of mechanical wave, 2 pi square n square a square rho c. Rho is the density of medium, c speed of wave, a amplitude and frequency. And whole this thing, actually, this part is called energy density of wave. Energy density of wave. I have discussed many times intensity of wave. Electromagnetic wave, you can try to understand definition of intensity of wave from the playlist of chapter electromagnetic wave. And in case if I take this, I am discussing here that light wave or electromagnetic wave, in that terms it is half epsilon 0 E 0 square into C, or B 0 square upon 2 mu 0 into C. E 0, B 0 are the magnitude of amplitude of the electromagnetic field. But here it is the electric field which is producing sensation of sight. So intensity proportional to square of amplitude. As we know that intensity I proportional to square of amplitude. So I can write that intensity of wave obtained by superposition of two waves y1 equal to a is given by small k into 4a square cos square phi upon 2. Phi I told you the phase difference, means direction of electric fields produced by two waves there. Actually many questions are asked in this term. A big number of questions is asked in this question. Now I come to here important point of interference of light wave. I told that when two waves of same frequency and nearly same amplitude, here I have taken same amplitude. So now I take here two sources of light. which are emitting light of wavelength lambda in same phase. S1, S2, anyhow, however, why I am telling why I am speaking, however, because it is not possible to obtain two independent sources which can produce light in same phase. But suppose I have taken, it is the midpoint. Here is a screen where the light falls from two sources. This point O lies on right bisector of S1, S2. So it is equidistant. Like this. Now I can think of the point P here. Sorry. Stay even on. Light can go this way here. What I am talking here, these are two sources of light which are emitting light of same wavelength lambda. You can write it yourself. Point this OP screen है, point O is equidistant from S1, S2. We know there is a relation between phase difference and path difference. Delta phi equal to 2 pi upon lambda into delta x. It is written as like this, phase difference. Delta phi the phase difference is equal to 2 pi upon lambda into path difference. This is taught in class 11. Actually, equation of progressive wave is like this: A sine 2 pi t upon t minus equation of wave traveling in positive direction having amplitude A time period t or wavelength lambda. This whole thing I am repeating again is called phase. So at any time t, the particle of different distance will have different phase phi 2 pi t upon t minus x upon lambda. If at any time t there are particles at distance x1, x2, phi 1 2 pi t upon t x1 upon lambda, phi 2 2 pi t upon t minus x upon lambda, and if you subtract, we get this type of relation. Here S1, S2 are two point sources emitting light in same phase. OP is screen, point O equidistance, so delta x 0. So if we consider any point P such that S2P minus S1P equal to plus minus n lambda. माइनस क्योंकि P इधर भी हो सकता है, तो S2P smaller than S1P तो नेगेटिव. Where n equal to 0, 1, 2, 3, n बराबर 0 का 1 point here equidistant. Then यानी कि S2 in fact S2P minus delta x path difference. But light going from this point here and this here. This is the path difference. If I cut PQ equal to PS1, so this represents path difference. So delta phi will be 2 pi upon lambda into n lambda, meaning 2n pi. Phase difference of 2n pi means wave meet in same phase. Phase difference 0. Why? By इधर डायरेक्शन है y1, y2 की अगर फेज में 2 पाई है तो वो भी यहीं आए घूम के. तो फेज डिफरेंस ऑफ 0, 2 पाई, 4 पाई एंड फेज डिफरेंस ऑफ इवन मल्टीपल ऑफ पाई of 2 pi. ये पाई करो, पाई means same phase. So at all those points where path difference is n lambda, light wave from two sources emitting light in same phase meet in same phase and give maximum intensity. What I have given I maximum. I prove क्या रिलेशन ना I maximum equal to a1 plus a2 whole square. और ऐसे I minimum क्या था फिर वो a1 minus a2 whole square. So if point P lies such that Ks2P minus 1P 9 lambda, so they will be same way. Now if P is such that Ks2P minus S1P is equal to 2n minus 1 into lambda by 2, then delta phi will be 2 pi upon lambda into 2n minus 1 lambda by 2. So it becomes 2n minus 1 pi. Phase difference 2n minus 1 odd number, where here n equal to 1, 2, 3. Here maybe plus minus also. Then two ways will be written and phase difference of odd multiple of pi means opposite phase. I agree that it is difficult to understand, but if you listen me carefully and analyze the facts, देखो y1 this way और y2 this way, तो 180 डिग्री यानी पाई का फेज डिफरेंस 3 पाई होगा तो फिर ये पाई 2 पाई 3 पाई फिर अपोजिट फेज, तो फेज डिफरेंस ऑफ ओड मल्टीपल पाई मीन्स अपोजिट फेज एंड हेंस if waves from two sources emitting light in same phase meet a point P with path difference of odd multiple of pi, they produce then the two waves produce minimum intensity. So this thing is there in mathematically. Again the video has become very long. So I have discussed superposition of light waves having different amplitude or same amplitude together, but you can choose one when you are discussing in exam. But both are important. Please see, and please, if you read my video, share the video, like the video, and tell your friend to watch my videos.